Good morning, good afternoon, or good evening. Wherever you are in the world, welcome and thank you for joining us. My name is Carl Anthony, and this is AutoVision News live at AutoSens and in cabin from the Auto World Museum in Brussels, Belgium. Broadcasting by the Bugatti Type 49 and Cadillac 341, we are immersed in the history of the automobile while simultaneously embracing its future here at AutoSens and in cabin. All of our broadcasts are live and then will be archived later on the AutoVision News LinkedIn page. Joining us now is Dr. Kirsten Matheus. She's an engineer and an economist, and since 2003, she has worked in the automotive industry and then at BMW since 2009, where she's responsible for the strategy behind in-vehicle networking technologies. Now, this entails ensuring the availability of suitable in-vehicle networking technologies ahead of time. And it's in this context that she successfully introduced Ethernet as a networking technology throughout the automotive industry. Kirsten is the author of two books, which we'll talk about in a moment, Automotive Ethernet and Automotive High-Speed Communications. Joining us today as part of AutoVision News Live at AutoSens and in cabin, Kirsten, welcome and thank you for being with us.
Well, thank you for the kind introduction.
Indeed. So tell us today about the work that you're doing with BMW.
So as you said in the introduction, it's my responsibility to ensure the in-vehicle networking technologies ahead of time. And I do my job well if the functional engineers, so the engineers that make the customer functions, can do whatever they want without being limited by the in-vehicle network.
Yes.
So the in-vehicle network has to be, I do it well if there is no restrictions, if it's not the limiting factor because too little bandwidth or too much latency or whatever you have. So it's my job to ensure they can do whatever they want so that the customer at the end is happy.
Of course. So what is special, Kirsten, about the relationship between Ethernet and automotive? What's the connection there?
So when in-vehicle networking started, it was sort of in the late 80s in the car. That was when electronics entered the vehicle, so the first engine control,
Yes.
the first little things. They realized relatively early that they needed a way to diagnose the electronics and the software.
Yes.
That was a case very early on. And at the time, they sort of made up their own systems. Everybody at the beginning also made up their proprietary system because car manufacturers thought it would be differentiating. Of course, the customer has no idea how you diagnose the engine and they don't care. But it took them a little while to even agree on that they would all, not agree, but sort of align on the same technology. So that's when the CAN bus came into play, and then they realized the CAN bus has limitations, so they invented the FlexRay and the MOS bus. So the industry always did their own thing. But with software updates and software flashing into the car and map data and larger amounts of data that needed to get into the car, the data rates increased.
Sure.
And then at some point, the question was, why always invent something new when there is a complete industry out there that's perfectly capable of handling networks and has done so 30 years ahead of time.
Yes.
So why does the automotive industry always need to reinvent? So this is when the idea came about to actually reuse. But then again, you have to think of what layer you are on. So on the physical layer, the car needs something that's light and that's EMC compliant. So electromagnetic compatibility needs to be met. So they needed to sort of somehow tweak a little bit the physical layer technologies that can be actually used in the car to put Ethernet networks on top. So this is how Ethernet got into the car, and how it's sort of the same and a little different.
Yes.
After all.
It's so interesting, Kristen, because about 12 years ago in my automotive career, I was a service advisor. I was at a Cadillac dealership, but we used to diagnose different problems, and you don't think about it. And you were right, the customer really doesn't care. They don't care that it's a differentiated system between a Cadillac or a Mercedes or a BMW. And then it's interesting you mentioned the lightweight component and how automakers are always concerned about weight and efficiency and things like that. So, Kristen, I took this one from our email. We were exchanging emails before we met up here in Brussels. This was something that Kristen and I were discussing over email. I thought I'd bring it here to the interview. But when the topic of future mobility arises, one of the most important areas of discussion is around the communication infrastructure. So, question, Kristen, what type of infrastructure is needed then to connect the sensors to the rest of the vehicle? And then further to that, what standards are needed in order to do so?
So when I say I need to enable the or the functional owners inside the car manufacturers to enable their whatever features they want to offer to the customers,
Sure.
I need to have some flexibility. And flexibility, for example, needs a network where you might attach a unit at different points in the network.
Yes.
Yeah, not always in every model. It might be in a different location simply because of physics, right? There's more space here or more space there, especially if you have something like open air, how you call that, rooftop cars when you take the roof off, cabriolets.
Yes, convertible, cabriolet, retractable fastback if you want to get fancy.
Convertibles was the name I was looking for, I apologize.
Convertibles, yeah.
You suddenly have different space restrictions in the car and you might put units somewhere else.
Yes,
and when you have something like Ethernet as a networking technologies, you're actually a lot more flexible than what you used to be.
Right.
Yeah, because you don't have to measure exactly, does it work in that location? Is it physically okay? So that's one of the things. The other is the scalability in the data rates.
Yeah.
At the edge of the network, you might have high-speed sensors, but you have lots of low-speed sensors as well. Sure. So you go sort of have these at locations you can't choose. Yeah. The sensor needs to be at a specific location. Other ECUs you might put somewhere where the customers, they don't see them anyway. Right. But the sensor needs to be where it senses the surroundings. So yes. You always need that network, but the idea is you sort of have the low data rate, you put it to the switch, Ethernet switch, and then you get the higher data rate where you accumulate it. And so in the end, you get the large data rates.
Right.
Yeah. And of course, when we're here at this conference, we talk a lot about cameras.
Yes.
Yeah, of course, they have the highest data. The data from the camera you get into gigabit data rate.
Sure.
So, but Ethernet scales over all of that, or I call it Ethernet-based communication.
Okay.
Yeah, Ethernet is not, as such, is not one technology. It's a packet format.
Yes.
And whatever technology you tunnel it over, it's all Ethernet. So I call it rather Ethernet-based. So as I talked yesterday, you have this new technology, it's called the ASA Motion Link, that can also transfer Ethernet packets. So it would be another technology that's then on the physical layer again, optimized weight, power consumption for asymmetric traffic.
Yes.
But it can still integrate, for example, in an Ethernet network if you want to.
Yeah. This is so fascinating. So you've written books on this topic, two of them, in fact, Automotive Ethernet and Automotive High-Speed Communications. Kristen, tell us a little bit about your books.
The first book, the Automotive Ethernet book, I had the idea or the need, let's put it like that,
Sure.
to write it.
Yes.
When BMW was the first car manufacturer to introduce Ethernet, and they started in 2008. And people were sort of curious, but they were sort of, frowning and looking upon it. And then 2000, Automotive Ethernet technology went in, and people were sort of still a little what are they doing? Hesitant. And then I went to the celebration of 40 years of Ethernet at the IEEE.
Yeah.
And I was there,
Yeah.
but they invited someone else on stage to speak for the automotive industry who was not from BMW. And I thought, why is this happening?
Sure,
Yeah, BMW is the innovator of this technology, and
Yes.
without us, it wouldn't be there. But they invited someone from another company
Yes.
to the stage to talk about it. And that company wasn't even very promotive of it
Right.
at the beginning. They totally changed later, I have to
Yes.
admit, but they
Yes.
weren't. And I thought, here is history being made in the wrong way. So I thought I needed to write it down. So
I love it.
it wasn't actually a very it was sort of a bit no, I wouldn't call it hurt pride, but I sort of thought, no, this is not right.
Sure.
I need to write it down how it really was, so
Yes.
that everybody can read about what was the history, how led to it, how did it come about.
Indeed.
And of course, there was a lot of curiosity in the industry.
Right.
It was
Right.
a new technology, people needed to know about it, and this is how, I mean, it's now in the 3rd edition. Yeah, it has always been extended with the latest news, so
Good.
it has a Chinese publication,
Oh,
translation,
fantastic.
and a Japanese one that's coming out
Awesome.
now too. So I mean, there is an interest in learning about it, and
Of course. Of course.
for me, it was always important in that book, especially, but also in the other, to write about not only what it is, but why.
Yeah.
Yeah, why did we take so they come along? What is sort of the history behind it? Because sometimes it's not the best technical decision that's being made.
Yeah.
Sometimes it depends on legacy, experience, or chance.
Yes. Yes.
That certain decisions are being made, and I wanted sort of to explain that too. And
Yeah.
I find from that book, of course, I've received a lot of feedback that people find that very valuable, especially engineers working with it find it valuable to also know all this sort of story, the background, what is Ethernet in general,
Of course.
what is networking in general in the
Yes.
car, and sort of to understand how it
Yes.
works. So that's that book.
Yeah.
And the other book now is on automotive high-speed communication for sensor and display applications.
Okay.
And that is something new also in the industry, so that the data rates are increasing so much. I've seen that before. And when we were working with it and trying to develop the new technologies like the ASA motion link, we also found that there is no good literature about it.
Okay.
And
Sure.
people don't know about what is really the case with the EMC. What's the real problem
Right.
in the car? How does it change when the frequencies increases?
Sure. Sure.
What cables do you need? What connectors? So it really has hardware too, plus all the application protocols and what is sort of the function, the history of the applications.
Yes. Yeah.
Displays is a little easier in this sense. People always had displays in the car. Of course, at the beginning, there were sort of analog dials.
Right.
But
yes.
ever since cars were being developed, and we can see that around here, they will
Indeed.
have some sort of dials or gauge inside the car where you can see the velocity or how much petrol you still have in the
Indeed.
tank,
Yes.
or these things.
Yes.
They've been there since the early 20th century, when cars were invented. So
Yes.
the need to exchange data with the customer was always there.
Right.
It slowly evolved to be digital, then you could exchange the type of data you used.
Right.
Otherwise it's one dial, one type of information.
Right.
And now it's sort of changed digital, people could get creative, it grew, and
Right.
so, but the sizes and resolutions we see now, we haven't had that before.
Right.
Anything near. So this is also new, and
Right.
we thought it would be good to sort of share that information.
Oh, it's incredible.
One thing I'd like to add.
I love this. This is amazing.
One thing I'd like to add, when you look for in-vehicle networking technologies like CAN or FlexRay or Ethernet or even MOST, there were all technologies that were sort of developed in standardization organizations in big communities.
Right.
So the industry learned as a whole. All different car manufacturers, everybody responsible for their technologies. There was is now a big knowledge base,
Right.
which is growing.
Right.
But these links for displays, for example, they were sort of more one link in the car, and it was a proprietary technology, and there is no common learning.
Right. Right.
But we've been in our department, and with Michael, whom I've written the book together with, we've been working with this for so many years now, and we found it doesn't have the same. So we also wanted to spread the knowledge and the experience we gained over the years with this technology,
Right.
and contribute to the
Yes.
learning of the industry, to ensure that it's just broader and better. People can take better decisions based on that knowledge.
It's so fascinating.
So,
And I know that you've probably answered this in so many words, but what inspires you as an author? I mean, there's a lot of inspiration there from the history and wanting to get the story correct, but what else is there? What really inspires you to write these books, would you say?
Well, one part is really I'm always interested in the background.
Yeah.
And when I write the book, I also need to have it 100% precise.
Yes.
So I really need to go back and check, is what I have in mind, how it is that really, can I prove it? Is it true?
Yeah.
Was it really like that? So I sort of like to be precise in this, but I also like to understand the whole system, the whole environment, the whole, what are the players, how does it work together. So for me, it's really, to have this context. I miss that when I read technical books so often. I sort of read the technical books and it sort of describes to me as, a very specific technical problems.
Sure.
Often it's sort of a repetition of a specification, more or less, and
Right.
a few more words, but I sort of, I really enjoyed looking at all this history. Like finding out that we have the fuel gauge in the car since 2017, 1917.
Yes.
Not 2000, 1917. So for me, that's, then sort of things come into place, and they also, I know what's important today.
Yes. Yes.
But it's also for me, it's really to be, to recap everything.
Right.
And to look at all those details that I don't have time to in my everyday work.
Of course.
That I would sort of maybe lose out on. And then I make sure they are there and they're written down. So it's a real, that's an inner drive to sort of
I love
be
it.
precise and get it right and understand everything.
Just amazing. Engineer and economist Dr. Kirsten Matheus from BMW, author of 2 books, Automotive Ethernet and Automotive High-Speed Communications. Both are available now. Automotive Ethernet in its 3rd edition with Japanese and Chinese translations available as well. Kirsten, I want to thank you so much for your time. Thank you for being with us, for sharing your thought leadership. And from all of us here at AutoVision News, we want to wish you the best of luck going forward, and thank you for being with us.
Thank you for giving me the possibility to share my thoughts.